Assalamu alaikum, welcome to my channel. The main reason I've made this video is because I know that most of the students are struggling with proving. Proving is a little difficult concept. Unless and until you practice a lot, it doesn't become easy. This is my humble attempt to try and make it easy for you. I will start with the textbook proving questions. First things first, you must have your trigonometry formula sheet ready with you, because when you are solving, you have to keep looking at the formula sheet and see which rule you can use. There are a few tricks that you can apply. You will have two sides, left hand side and the right hand side. Some students have learned that they solve left hand side and right hand side simultaneously. That is not acceptable. You have to choose left hand side or the right hand side. To choose the side, it is always better to choose the more complicated side first, as it is more easier to make complicated things simple than the other way round. Next, usually the side with the trigonometric identity with the power 2 is better to use, as there are many identities that have trig identities with the power 2. For example, we have the Pythagorean formulas: sine square a plus cos square a is equal to 1, sec square a is equal to 1 plus tan square a, and cosec square a is equal to 1 plus cot square a. And also the double angle formula for cos. Each one of them has a square. Also choose the side with the number 1. If you have only 1, choose that side, as there are many identities that has a 1. These are the Pythagorean formulas. If I have 1, I can replace it with sine square a plus cos square a. If there is a 1, I can replace it with sec square a minus tan square a. And 1 can also be replaced by cosec square a minus cot square a. The most common used algebraic identity is the difference of squares. That is a square minus b square is equal to a minus b and a plus b, both in brackets. Let's start. I have written down the formulas here that we might need, and we'll start with exercise 3a, question number 8a. This is the left hand side and this is the right hand side. There are squares in all the identities, so it doesn't make a difference which you choose. Look here, there is sec square a is equal to 1 plus tan square theta, and cos square a is equal to 1 plus cot square a. So I'm going to choose the left hand side, as I don't have to make any adjustments. In place of sec square theta, I'm going to replace 1 plus tan square theta. You replace the a with the theta. Minus, in place of cosec square, we are going to use 1 plus cot square theta. Expand the bracket. Please be careful about the signs. The signs are going to change. Negative cot square theta. 1 minus 1 is 0, and we are left with tan square theta minus cot square theta. These easy questions, they come in multiple choice, but they have stopped the multiple choice in the last few years. Now part B. I told you to choose the one where there is a 1, so we will choose the right hand side. What do we replace with? We have got the 3 identities that we can use. I told you the Pythagorean formulas. You have sec theta minus tan theta. With what can they get connected? With this identity, right? So the tan square theta, I'm going to bring it to the left hand side, and that will give me 1 is equal to sec square theta minus tan square theta over sec theta minus tan theta. Whenever you see there is a square, you have to remember your algebraic identity, a square minus b square. Our a is sec theta and b is tan theta. So a minus b and a plus b. The sec theta minus tan theta will be cancelled. We are left with sec theta plus tan theta, which is equal to our left hand side. In 8c we have sec theta plus cosec cot theta is equal to sec theta cosec square theta. Before you listen to what I have to say, pause the video and try to see if you can solve it. Do that for each question. There is a square here, so we are going to use the right hand side. Replace the cosec square theta with 1 plus cot square theta. Expand the bracket. You will get sec theta plus sec theta cot square theta. What do you want to find? You want to find sec theta plus cosec theta cot theta. You already got the sec theta, so leave it alone. Don't make any changes to it. And here you want 1 cot, okay? We have cot square theta. It is like maybe 3 square. So 3 multiplied by 3. It's the same thing. So I can write here sec theta multiplied by cot theta multiplied by cot theta. We already found 2 terms. Now we just have to simplify this part here. Sec theta is the reciprocal of 1 over cos. So we will change that. And cot theta is the reciprocal of 1 over 10. But remember, whenever you have a sine or a cos, use this identity and not this one. So I will replace cot with cos over sine. The cot theta, we don't want to make any changes. This is cancelled. And we are left with sec theta plus 1 over sine theta. What is 1 over sine theta equal to? Cosec theta. And you have the cot theta. This is equal to our left hand side. Having the identities right next to you when you are solving is very essential. Moving on to 8t. Sine square theta bracket 1 plus sec square theta is equal to sec square theta minus cos square theta. Again, there is square everywhere. What should you use? The left hand side. Even the right hand side will work. It's not that it won't work. But it is always easier to expand than to factorize. That's the reason we will choose the left hand side. Sine square theta we have here. So if I bring the cos square here, it will become 1 minus cos square a. I can replace that with sine square a. 1 minus cos square theta bracket 1 plus sec square theta. Expand the bracket. Be careful. 1 multiplied by 1 will give us 1. 1 multiplied by sec square theta will give me sec square theta. Negative cos square theta multiplied by 1 is negative cos square theta. Negative cos square theta multiplied by sec square theta is negative cos square theta multiply sec square theta. Again, keep looking, always keep looking at what you want. You want to find sec square theta minus cos square theta. We already got that. So the other things are the extra things that we don't need. We can't do anything with the 1, so we leave it. But the cos square theta we can leave it the same way, and sec square is the reciprocal of cos. So instead of sec square, I can write it as 1 over cos square theta. This will cancel out the cos square theta and leaving us with 1 plus sec square theta minus cos square theta minus 1. 1 minus 1 is cancelled. Now we have sec square theta minus cos square theta, which equals our right hand side. Moving on to the next and the last question of 3a, we are going to choose the right hand side. And I'm sure you know the reason why we are choosing the right hand side, because there is a 1 because of that. Now you also have a 1 here, but in the denominator you have cosec theta plus cot theta, and we can connect cosec and cot with the 1. If I shift the cosec square theta here, no, I'll shift it the other way. Just a second. Here, so I will have cosec square theta minus cot square theta is equal to 1. So in place of 1, we substituted cosec square theta minus cot square theta. And in the denominator, we have cosec theta plus cot theta. Again, we are going to use a square minus b square, which will be a minus b and a plus b. Our a is cosec theta and b is cot theta. It doesn't make a difference if I write a plus b or a minus b. They are both the same. And in the denominator, we have cosec theta plus cot theta. We can cancel this out. We are left with cosec theta minus cot theta. We did a question previously, and this was our answer. But in this question, we have a different thing to prove. So we will have to continue. That's the reason it is important you keep looking at what you need to prove. Cosec can be written as 1 over sine theta, and cot, the same thing which I told you, that you can replace it with 1 over tan or with cos over sine. Because there's a sine involved here, I'm going to use cos theta over sine theta. As the denominators are same, I can join them together and write it as one fraction. And we proved. I hope you have understood at least a little bit. It requires practice. For 3D, I will continue in part 2. Thank you for watching, and do share it with your friends so that they can also benefit.